Welcome to Efiwe, excellence without stress.
Hi guys, I'm back again. It's me again, your favorite physics tutor, Miss Stella, and today we're taking a new topic, which is gas laws. The gas laws are a group of laws that govern the behavior of gases by providing relationship between the following: the volume occupied by the gas, the pressure exerted by a gas on the walls of its container, the absolute temperature of the gas, and the amount of gaseous substance or the number of moles of gas. The gas laws were developed towards the end of the 18th century by numerous scientists, and we have 5 gas laws. We have the Boyle's law. This one provides relationship between the pressure and the volume of the gas. We have the Charles law. It provides relationship between the volume of the gas and absolute temperature. We have the Gay-Lussac's law. We have the Avogadro's law, and we have the combined gas law. Boyle's law. Boyle's law is a gas law which states that the pressure exerted by a gas of a given mass kept at constant temperature is inversely proportional to the volume occupied by it. That is, Boyle's law states that the pressure of a given mass of gas is inversely proportional to the volume. That is, as the pressure is increasing, the volume is reducing, and as the volume is increasing, the pressure is increasing. It's inversely proportional to the volume occupied by it. For a gas, the relationship between the volume and gas can be expressed by this. Since P, which is pressure, is inversely proportional to V, so we can have it like this. And you know that if you are changing proportionality sign to equals to, you introduce a constant. So we have PV is equals to what? Is equals to K. So P1V1 is equals to P2V2, where P1 is the initial pressure exerted by the gas, V1 is the initial volume occupied by the gas, and P2 is the final pressure exerted by the gas, V2 is the final volume occupied by the gas. So we have a question here. A fixed amount of gas occupies a volume of 1 liter, that is the V1, and exerts a pressure of 400 kilopascal on the walls of its container, that is P1. What will be the pressure exerted by the gas if it is completely transferred to a new container having a volume of 3 liters? So we are looking for P2. So we already know that. So if you want to get the relationship for P2, you know what we are going to do, right? Since we have P1, we have P1 V1 is equals to P2 V2. So getting P2 will definitely be what? P1, right? V1 over what? Over V2. And that is what we are going to use. That's what we are going to use to get it. So P1 V1. So let's go to the next slide. So given that pressure is 3 kilopascal, final pressure is 6 kilopascal, and final volume is 10 liters. So, and we are looking for what? V1. Okay, it's V1 we are looking for, not V2. Okay, find the volume. Sorry, we are looking for our V1. We are looking for our V1. Final volume is V1. Okay, increases to 6 kilopascal. Okay, so therefore the volume of the container is what? 20 liters. If you do the right multiplication, 6 kilopascal multiplied by 10 divided by 3 kilopascal, you get 20 liters. This is a very simple thing, and I'm sure that it will not take you long to understand. Therefore the volume of the container is 20 liters. So an 18.0 milliliter sample of gas is at 3.500 atmosphere. What will be the volume of if the pressure becomes 2.500 atmosphere with fixed amount of gas and temperature? It's the same process. You have P1 V1 is equals to P2 V2, and we are looking for our V2, and if you put in the right parameters, you will get your answer. Charles' law states that the volume of an ideal gas is directly proportional. So this one is directly proportional to the temperature. As the temperature increases, volume also increases. That is another law. Charles' law states that the volume of an ideal gas is directly proportional to its volume. Directly proportional to its temperature at constant pressure. Volume is directly proportional to its temperature at constant volume. The law also states that Kelvin temperature and the volume will be directly proportional when the pressure exerted on the sample of the dry gas is held constant. So here we have V1 T1 is equals to V2 divided by T2. Charles' law application in real life. This law has a wide application in daily life. Some are explained below. In cold weather or in cold environments, helium balloons shrink. You know that we are saying that the volume is directly proportional to the temperature. In winter, when the weather is cool, the capacity of the human lung decreases. This makes it more difficult for the athletes to perform on a freezing winter day, and also make it difficult for people to go jogging. So this is a question. A gas occupies volume of 400 cm cube at 0 degrees Celsius and 780 milliliter of mercury limiter of mercury. How many liters of volume will the gas occupy at 80 degrees Celsius and 70 mm of mercury? So according to the question, we have our V1 as this. Your theta, you know, you have to convert temperature 2 degrees Celsius. So you have to add 273 to it to convert it to what? Kelvin. The temperature is in Celsius, you have to convert it to Kelvin. So you add 273 to it, to the initial and to the final temperature. Then using Charles law, which is V1 divided by T1 is equal to V2 divided by T2, you can get your V2. Same thing with this one. A sample of carbon dioxide in a pump has a volume. This is the volume and is at 50 degrees Celsius, which is the temperature. You know, we have to convert this temperature. When the amount of gas and pressure remain constant, find the new volume of the carbon dioxide in the pump if the temperature is increased to this. So you look for the final volume using your normal temperature, this V1 T2 over T1, and you will get your answer. Combined gas law. The combined gas law, also known as the general gas equation, is obtained by combining the three gas law, which is Charles law, Boyle's law, and Gauss-Lussac's law. The law shows the relationship between the temperature, volume, and pressure for a fixed quantity of gas. The general equation of combined gas law is given as PV over T is equals to K, and we can have it as P1V1 over T1 is equals to P2V2 over T2. So ideal gas equation. The ideal gas law is the equation of state of hypothetical ideal gas. It is a good approximation of the behavior of many gases under many conditions, although it has several limitations. Thus, the ideal gas equation is PV is equals to nRT, where P is the pressure, V is the volume of the gas, N is the amount of ideal gas measured in terms of moles, R is the gas constant, and T is the temperature. What is the volume occupied by 2.34 grams of carbon dioxide gas at standard temperature and pressure? Standard temperature and pressure. So determine the volume. Rearrange the ideal gas law as follows. You know that V is equals to nRT divided by P, because PV is equals to nRT, right? So our N is 2.34 divided by 44 and is equals to 0.053. That's our N. Our R is equals to 8.314 joules per joule per mole per Kelvin. T is 270 because they said it's at standard temperature. So I'm going to use the standard temperature. I'm going to use the standard pressure. And this is carbon dioxide, that's CO2. So you have to get the number of moles. Number of moles is mass divided by the molar mass. That is why you have N is equals to 2.34 divided by 44 to get your N. N is number of moles, and number of moles is mass divided by the molar mass, and that's how we have it here. Your R is the standard is R is equals to 8.314 joules, because we're saying is in standard temperature and pressure. Standard temperature and pressure. R, which is the gas constant, is this. Then we have your T, standard temperature 273 Kelvin, and standard pressure is this, is 101,325 Newton per meter square, and this is your volume. So to get your V is just what? N multiplied by R multiplied by T divided by P, and you will get this. This is another question using the same process. You will get it. Calculate the temperature at which 0.654 moles of neon gas. This is the mole. So with using our PV is equals to nRT, we can get our temperature. For ideal gas with number of moles being 1, PV is equals to nRT, where N is equals to 1. So PV will be equals to RT. If N is equals to 1, PV is equals to RT. So R is universal gas constant, T is temperature, and P is pressure, and V is volume. So this is all about gas laws. You know, it is a very simple topic, and I know you must have done it in chemistry, and it's just going to be so simple for you. Thank you. See you in the next class.